these things, and from this PPT you can create some of the PPTs, because this is the big PPT. I write shortly, but you also write short points only, and you think that as per your knowledge you prepare your PPT. Not all the content will present in that PPT. You can select particular lines, and you can explain in such a way that everybody should understand, and somebody will ask the questions, you can also answer the questions. So these are the some of the learning objectives you can write. There are I write 4 to 5 learning objectives, 4 learning objectives. You can write 2 learning objectives about our mastering system. You can take simple harmonic motion and simple mastering system motion. You can take. You know that this is in natural position. The spring is like this. If you give some mass, then what happens? This will be moving upward and downwards. If that is a constant position, that is called equilibrium position. That in that time, mg is equal to ks. Means this displacement is fixed. That displacement, and here the up direction and down direction both are in equilibrium position. That means constant position. If here this is a 2 different positions like that, minus x and plus k, you can write. Then its motion will be this is our this is moving upward and downward position, and you're getting that oscillation motion of oscillatory motion. You see here written that 17.3.1 spring in natural position, first one. Then equilibrium position means constant position, that is your second one. Means that is mg is equal to ks. And here oscillatory motion, you can know that this is oscillation upward, downward. This is spring is like upward direction and downward direction, that is moving. Then that is called the in motion position. Next, there are the how to get that differential equation. What are the concepts? You know that displacement, mass, equilibrium, whatever I discussed now on the figure. All the things are available here, and how to get that using you know that Hooke's law. Apply that Hooke's law, and apply that Hooke's law, you can get the differential equation, accelerated differential equation. Once you get the accelerated differential equation, whenever both are that means equilibrium position, mg is equal to ks. Then what happens? This term, this mx double dash and this minus ks is equal to mg, then this part is 0. So we are getting only minus kx. And if you write in one left hand side, you are getting this second order differential equation. If m and k are given to you, then you can find out the solution, and accordingly we can follow that solution format. You know that second order differential equation. Who is that? Mute first. Here you check that who is that. I will give absent then. Alright. Roll number क्या है इसका? Saurav, I will give it absent. Okay, no problem. Now Saurav. Now this is our sorry. So this is our second order differential equation. If you solve for the second order differential equation, this is our we are getting that roots are complex conjugate type, and from the complex conjugate roots, we are getting the solution, that is C1 cos omega x plus C2 sin omega x. After getting the C1 cos omega, C2 sin omega x, and if you take some initial conditions like this, if you take the initial condition t is equal to 2 pi by omega, then what happens that f of t represents sin 2t, and the graph of this one is sin 2t. You know that sin function is sin 0, sin 2 pi, sin 3 pi, sin 4 pi, sin 5 pi, all are 0. So remainings are, and sine function slice between -1 to 1, the graph of that sine 2t. And here, example 1. So mg and ks, you know that, and mg ks have given that the values. and you can put all the values and find out k, and then after that you can put in that equation mx double dash plus kx is equal to 0, put all the values and you get the solution. This is the one example. The damped vibration, what is damped vibration? You can read this one, and you don't take all the things, okay? You take minimum things and you can explain one by one. And not only for the my examples, you can collect some examples from internet and you can follow the PPTs. And because this is marks fetching, because if your presentation is good, automatically you're getting good marks. That's why you can follow this PPT, not use same content also. If you want to change some content, you can change it. Okay. Then this differential equation, mass spin system differential equation, this is our mx double dash bx dash and kx equal to 0. And if you solve for this quadratic equation, and we are getting that roots, two roots are, whatever the roots are getting, the roots are different. This is the solution. And one is positive, one is negative, like this. Graphs are here. So then go to the example 2. You can put all the values in that differential equation. You get the two different roots, and roots are -2 and -3, and solve for the roots. We're getting that solution format. And after that, if you are taking some initial conditions, you are given that initial conditions, then you can follow that x of t and find out the values, and you can show the. Then similarly, critically damped vibration. What is critically damped vibration? You look down from B.B. Ramana book and you can understand the things. Then you can critically, what is critically damped vibration? You can follow that. And then critically damped vibration means that his roots are equal type. Okay. So roots are equal type. How to get that results, and what are the solutions? You see, critically damped vibration also in same in your second order differential equation. Whenever you present that second order differential equation, that is also present. So next, you take one example and solve that example and find out the result. That is called, you can say that because roots are same type, then this is the critically damped vibration possible. Okay. So undamped vibration, which is undamped means that is your sine, cosine both are there in equilibrium position, and you can say that is undamped vibration, and you can follow that result, and you can take one example to show this. That's all. Is it understand what to do? You take any two, either harmonic motion or critically damped or undamped, and damped vibration. There are different things are there. I already shared this PPT. Yes or no? You follow this PPT and you can prepare as per your own, and you can present from Monday onwards. Is it okay?
Okay, sir.